All right, we're ready to look at the next functional group, and actually it's two groups. It's aldehydes and ketones. Aldehydes and ketones have this similar group, and we call it a carbonyl group. You see there what's in blue on the screen? The carbonyl group is that C double bond O. Now it depends on whether or not we've got carbons on either side of that carbon, or one of them is a carbon and one is a hydrogen. Depending on what we see there, we are either dealing with an aldehyde, which we know it has the hydrogen attached there, or we're dealing with the ketone, and we know that it's going to have carbons on both sides, okay? So you need to be able to recognize them. But what this little lesson is about is looking at the properties of aldehydes and ketones. Where would you see these in nature or in the world around you? So let's relook at that. That's called a carbonyl group, okay, that we see there. And that is seen within the aldehyde and within the ketone that we haven't seen up to this point, okay? Aldehydes and ketones are common products when alcohols react, okay, with oxygen. So if, and this is true with, let's say you have a bottle of wine, you open the wine, you drink some wine, and then you don't finish the bottle, which I don't recommend a person finish the bottle of wine. If it sits exposed to oxygen, then it is going to naturally convert over to an aldehyde in this case. Some other alcohols, depending on where the OH group is attached, it might turn into a ketone, okay? So what we say is, all right, if it's going to react with oxygen, that the aldehyde and the ketones are, and let's skip right down here, are said to be more oxidized than alcohols. Okay, so we'd have alcohols being more oxidized than an alkane. Let's say, oops, come on, don't do that to me. Okay, so we have CH3, CH3, that's an alkane. There's no oxygen in there. Then we could have CH3, CH2OH. That is said to be more oxidized than the other. So we're going in the direction of becoming more and more oxidized, and that's what that little square bracket O means. I'm going to oxidize it to turn it into that. And then this could be converted to having a double bond here instead. And that is more oxidized than the other one. And it could go further, but we're not going to here. Let's go through from the simplest. The simplest aldehyde is going to be formaldehyde, okay? Formaldehyde is toxic to humans. It's toxic to animals. You've heard of the term formaldehyde if you've been in a, probably anyway, in a biology lab somewhere along your life. So it's the simplest aldehyde. Now, not only does it have hydrogen at one of the locations, it has hydrogen at the other location. So it can't be a ketone because those two have to be C's in order to be a ketone. So this is the simplest aldehyde. Its common name is formaldehyde. We're not going to learn the naming system of aldehydes and ketones, but this is its common name. But it is so common that nobody wants to call it by its IUPAC name, which is, I'll write it down, methanol. Okay, an AL ending is what we use for aldehydes. So this is actually a gas, and you're like, I thought it was a liquid. I thought you put specimens in it. You put the brain that you collect into formaldehyde. Well, it's actually a gas. So it's a gas under normal temperatures and pressures. What is it used for? Well, it is a plasticizer. Sometimes it's put into plastics to give it some flexibility. It's losing favor in that realm. A lot of times they don't want to expose you to breathing in a lot of formaldehyde. So it used to be that a carpet, when it was laid out and it really would smell very strong, that would be formaldehyde coming out of the carpet that was used as a plasticizer. And it's that strong smell associated with it. But that is less and less the case anymore of using formaldehyde as a plasticizer. But this is what it's often used for. It's used as a preservative. It's used as an embalming fluid. And in order to be used as a preservative or an embalming fluid, it has to be dissolved into water, okay? It could also be used as a disinfectant. It can kill bacteria. So it's dissolved in water and it's made a solution, and that solution is actually called formalin instead of formaldehyde. So when I say it's 40% solution, that means 60% water, 40% of the formaldehyde. That mixture right there is your formalin mixture. So if you go into a biology lab and they say they've got this preserved, it is probably preserved in this formaldehyde. Okay, so aldehydes in general. Now, formaldehyde doesn't really fit this bill, but aldehydes and ketones sometimes have a pleasing odor, a pleasing taste. They can be found in foods. They can be found in perfumes as well. So let's, aldehydes, you might see them in fruits and in other plants to give them good flavor. Here are some examples, okay? So I don't want you to memorize that structure. I do not want you to memorize the name of this compound, but I want you to be aware that if you saw this, that's an aldehyde, okay? And that benzaldehyde is actually in almonds, and it gives us some of that almond flavor. Here is vanilla. In naturally occurring vanilla beans, you have this compound. The compound is actually called vanillin. And if you buy artificial vanilla, they have just taken that chemical right there and they've dissolved it in alcohol solution. But in naturally occurring vanilla beans, it has this compound, and we see the aldehyde group right there. Now, it's not the only group associated with that. You ought to be able to recognize other groups in there. Can you find the alcohol group, the OH group, which is the alcohol group? Can you find an ether? See that oxygen on either side of the oxygen is a carbon, so there's an ether. But it is, that aldehyde group is commonly seen in things that are pleasing to the taste and to the smell. Now, ethers aren't known for that. Alcohols are not known for that, but aldehydes are. So it's probably the aldehyde that gives vanilla to us a good flavor. Here is cinnamon aldehyde. It is an aldehyde as well. Okay, so you ought to be able to recognize that. So I don't expect you to memorize these compound names or their formulas, but I do want you to know that very often we have chemicals within our foods that are aldehydes that we associate with pleasant odors and flavors. And then you ought to be able to, if I gave you those compounds that you see there, if I gave those to you, you ought to be able to recognize the aldehyde group that you see there. All right, so here's some information about ketones. We know that ketones also has that carbonyl group. It's got the C, it's got the double bond to the oxygen, but a carbon on either side, okay? Anything that is a ketone is going to have an ONE ending. For the aldehydes, which I didn't really mention that, the aldehydes are going to either have an ending of aldehyde, like formaldehyde, okay? Easy to know that's an aldehyde. Or they will have an AL ending. Okay, and that's coming off of this AL beginning. So that is a recognizer of formaldehyde, or aldehydes. And in our examples, we had aldehyde in their names. For ketones, they're going to have an ONE ending, and that is a recognizer that you're dealing with a ketone. Okay, so here is the simplest ketone. You're going to have at least one carbon on either side. So I have a methyl group here and a methyl group here. It's got a common name of acetone. Acetone we're familiar with. Acetone we see in, well, maybe not all of you are, but acetone is the solvent in fingernail polish remover. Okay, so it is a really good solvent. It dissolves things very, very well. So like it says, nail varnish remover, fingernail polish remover is what acetone is used for by the gallons. And that is a ketone with a methyl group on either side. Methyl ethyl ketone, which has a, out in the industry is very often called MEK, would have a methyl group on one side and an ethyl group on the other side. And this is another really good solvent. It would be good for a nail polish remover as well. It smells a little stronger than acetone does. It's not very pleasant to smell, but it could be used very nicely. It's a very good solvent for anything that is organic. So let's just draw a picture of methyl ethyl ethyl ketone. So we have our oxygen, that's our carbonyl group. We would have a methyl group on one side and an ethyl group on the other side. Now that would not be its IUPAC name. We're not going to get into the IUPAC name right now. And we just did. We drew methyl ethyl ketone. Okay, so that's the discussion that I wanted to give you. And let me back it up here so we've got that image. That's the lesson I wanted to give you about aldehydes and ketones, what they look like, and some common places that you would see it. The ketones are not commonly, I don't have any common examples of it as a pleasing aroma, but the aldehydes certainly are. You'll see them more as a food additive or actually part of organic foods that we like to eat.